Hi, I'm Cynthia from the Center for Mathematics and Teaching. If you don't know us or our work, we're a nonprofit and we develop middle school mathematics curriculum and resources, plus we support teachers in using them. We've worked together in the math department at UCLA for about a decade. Then about 12 years ago, we left the university to form CMAT. So let's get started talking about the world of sixth grade inputs and outputs. The ideas we'll be sharing with you today are taken from our sixth grade course. For some quick perspective, you'll notice here that this content is in the 7th packet of 10 packets that make up the sixth grade course. We really think you'll like the approaches you'll see and hopefully want to use them in your school or district. As our goals today, we're going to focus on some important sixth grade standards, explore various representations using a variety of problems, and see ways to really get at a solid conceptual understanding of ratio concepts. And you'll have the perspective of seeing what we think are unique and interesting approaches to the content you're expected to teach sixth graders. So let's get started. As a hook, or creating the need to know, we start with an opening problem. In this case, we'll be creating the need to know for the coordinate plane. As a reminder, graphing in one quadrant was introduced in grade 5, and graphing in 4 quadrants will be introduced later in 6th grade. So let's start with an opening problem. We are going to run through a scheme that accompanies this opening problem. To start, students pick a dot and keep their choice to themselves while writing the location description. You may want to have a few students read their descriptions aloud to the class while other selected classmates try to guess the point's location, or this could be used as a pair activity where students read each other's descriptions and make guesses. As we go through some slides, blue numbered text suggests written responses. Students will find their same dot from the previous slide and review some important vocabulary. Students will then use this vocabulary to help to describe where their dot is located. Drawing attention to the italic question meant to spark a discussion, we encourage the use of academic language so that students refer to specific axes or the origin as reference points. Students write a new description for the same point. Then discussion can be made around how the grid helped with the description. Regardless of prior experience with the coordinate plane, students can count number of units from reference points like the origin or the axes. This could be used as a formative assessment to see if students remember that graphing in the first quadrant involves starting at the origin and counting to the right and then up. We would encourage students to share as they did for the previous slide. On this final slide of the opening problem, students write their final description, which can be as simple as stating the letter for the point. Collectively, these slides should highlight the utility of graphing in the coordinate system. Just to let you know, this packet has 3 lessons. So now we are ready to look at our first multi-day lesson. This lesson will take about 3 class hours. Each new lesson begins with a getting started page, which introduces goals and warm-up problems. In this case, doing more formal work with the coordinate plane and vocabulary. Let's start with the first lesson of this section, what comes next. In this lesson, we focus on growing geometric patterns for a review of multiple representations. For example, students will record numerical data and tables and graphs using a context that shows a relation between 2 variables and a connection to rates. Here is a student page from the student packet. As you can see, it is mostly blank and gives students organized space for their work. On the right is the finished product, which is the answer key. Now, let's look at how this plays out. We start with a growing pattern and ask students to build the first 2 steps, and then a third step that makes sense to them. Many students benefit from building each pattern with square tiles prior to drawing it. Students then write descriptions on the growing pattern and are asked to describe their third step. Once again, students can share as desired. We then look at Mateo's and Anita's third step. Even if students have already come up with these options, this is a great time to discuss why both of these answers can be correct. Mateo sees the pattern as starting with 2 tiles and adding 2 more at each step. Anita sees it as starting with 2 tiles and doubling at each step. Students will then continue to draw steps 1 through 4 for both patterns. On this slide, we focus on tables to organize our work. We discuss titles and column headings as needed, and then students complete the table for both and start Mateo's table entries. Students then complete graphs for both. If needed, discuss good titles, access labels, and access numbering, and remind students that entry pairs from the table act as ordered pairs. Students then graph the data. You can discuss how Mateo's points appear on a straight line, and though we don't have it here, by contrast, discuss Anita's points that appear on a curve. Our work with growing patterns leads nicely into input-output rules. We revisit growing patterns and their corresponding tables of values to focus on the relationship between the independent variables and the dependent variables. Students will also begin to write these relationships in words and equations as input-output rules. We revisit Mateo's pattern to focus on the relationship between the input values and the output values, and then discuss input-output rules, focusing on the fact that we multiply the x value by 2 to get the y value. Students then write an input-output rule for Mateo's pattern in words and using an equation. This slide is used to connect the concept of input and output values to the vocabulary of independent and dependent variables. Now let's talk about why we have chosen our approach and where it goes in 7th grade. For equations in slope-intercept form, which is a later grade goal, we first think input-output. So we have y equals x plus b, or y equals mx, which are examples of inputs and outputs, and are related equations that solve for the unknown in one variable, while developing the understanding of a proportional relationship, which is not relevant now, but more formally studied in 7th grade. So let's talk more about Mateo's equation, y equals 2x. This is what we hope goes through students' minds as we do more of this work. I have the step number, so I need to substitute. Or I have the total number of tiles, I need to solve an equation. Moving on to lesson 2 is, slide 23, take 2. Moving on to the second lesson, in this section, we'll be comparing prices. Slide 23, take 3. Moving on to lesson 2, this lesson, comparing prices, takes about 2 to 3 class hours. We start this one with the keychain fundraiser. Students start by reading and understanding what is needed, then copying the pricing information for high tops and create the 3 representations. This is a review, so discussion will happen as needed. This slide focuses on the connection of the double number line to a coordinate graph. Notice how quantity moves and becomes the x-axis, and the cost becomes the y-axis. Then students complete the graph. Students complete the same representation for donut keychains. There are many discussions that may come up, such as donut keychains are a better buy in terms of price per one keychain, the unit rate, but this does not necessarily mean they are preferable for the fundraiser, or that you could even just buy one. Finally, in lesson 3, rate application at slide 27, take 2. Finally, lesson 3 is on rate applications and takes about 2 to 3 class hours and starts with raising money for music. Here we analyze a fundraiser effort. Stop. Slide 27, take 3. Finally, lesson 3 is on rate applications and takes about 2 to 3 class hours. It starts with raising money for music. Here we analyze a fundraising effort using tables and equations, but we also consider that the independent and dependent variables might change based upon our focus. Attention should be focused on the problem context and the problem stated on the slide. I'm not even sure if this is working, but we're going to keep going. That was a stop. Slide 28, take 2. Attention should be focused on this problem context and the tables started on the slide. What's the same for each table? They both keep track of the number of trees sold and money earned in dollars. What's different with each table? The variables are switched. In table 1, number of trees sold is the input and money earned in dollars is the output. Table 2 is the opposite. The input or output can vary depending on what the focus is. We want students to make sense of both. Students copy the cost of a tree and complete the tables. On this slide, we pose sentence starters for each table and discuss. For the first table, the amount of money earned will depend upon how many trees are sold. In this case, the trees are the independent variable and the amount of money is the dependent variable. In the second table, this may seem less obvious. We might think about a fundraising goal in such a way that the number of trees we want to sell depends upon the amount of money we want to earn. In this case, the amount of money is the independent variable and the number of trees is the dependent variable. So what you just saw was the main lessons for this student packet. The MathLinks program focuses, stop, slide 30, take 2. What you just saw was the main lessons for this student packet. The MathLinks program focuses around the big ideas of 6th grade. Today we looked at ratio and rate reasoning and representation, worked on our computational fluency, explored inputs and outputs, solved equations, and in just a minute, I'll show you how we link the keychain fundraiser to statistics. Teaching with an eye on big ideas allows for more connections to be made and more efficiently get through the stop. I think this might be take 2. Slide 30, take 2. Let me go backwards. Slide 30, take 2. You just saw the main lessons for this packet. The MathLinks program focuses around the big ideas of 6th grade. Today we looked at ratio and rate reasoning and representation. We worked on our computational fluency, we explored inputs and outputs, we solved equations, and in just a minute, I'll show you how we link the Keychain fundraiser to statistics. Teaching with an eye on big ideas allows for more connections to be made and to more efficiently get through all of the important content of 6th grade. Now I'd like to show you where you could find out more, especially how to access these lessons. This is the cover of our 6th grade student packet 7 that we just went through, called Inputs and Outputs. Here is the link to the student packet electronically. Start over again. Slide 32, take 2. Here's the link to access this student packet electronically. After you complete a short form, you can try a lesson or two, or the whole packet, and you'll have access to all the relevant teacher materials to help you implement the lessons. Or if you're looking for a new middle school curriculum and are interested in a more formal pilot, we'd certainly love to work with you on that. We offer a free class set of consumable student packets, access to teacher materials, and virtual support. There's info on our website, which you'll see again. And even though we're looking at 6th grade now, there are similar 7th and 8th grade pilot options as well. I'd like to quickly show you a couple of other features and resources, just so you have a better of idea. Stop. Slide 35, take 2. I'd like to quickly show you a couple of other features and resources, just so you have a better idea of what you'd be getting. Here is the cover of the student packet again, that takes about 14 class hours to complete. At the front of every packet is a word bank that students fill in as new vocabulary is introduced in context. Near the end of each packet, there's a crossword puzzle to practice the vocabulary. There's lots of practice throughout the student packet, along with some practice that will be extended. Stop. Slide 38, take 2. There's lots of practice throughout the student packet, along with some practice that will extend students' thinking. Often, problems get revisited. Here you see the keychain problem gets extended to include statistics. Since this page is very task-like, you can use our MathLinks rubric to get students involved in giving each other feedback. There are typically 3 review activities at the end of each packet that engage students to work together. Every packet has a spiral review section, usually about 2 to 3 pages of problems that review work from a previous packet or previous grade as necessary. On the right is our reflection page. It can be powerful when students reflect on their own learning. You'll notice a few places this happens throughout the packet, but this page near the end is a more summative reflection. One thing you'll notice is our big idea wheel that contains what we consider to be the 7 big ideas of 6th grade. As we saw earlier, this packet gives students the opportunity to shade in 5 of those 7 big ideas and to note the connections between some of them. This very last part of all stop. Slide 42, take 2. The very last part of all packets has definitions and examples. I don't think I paused long enough. We're going to stop again and do a take 3 in case we need it. Take 3, slide 42. The very last part of all packets has definitions and examples. There's a teacher edition with a lot of helpful information that you could choose to read as background or for implementing the lessons. You've also seen a few red answer key pages along the way. When there are slide decks, such as the ones we saw earlier, they're accompanied by concise lesson notes and an alternative page that can be used on a dock camera or for other lesson delivery ideas of your choice. In other words, you teach the content the way you want. A variety of assessments are provided, both formative, many of which are in the student packet, and summative. There's plenty of extra resources aimed specifically at struggling learners and some for all learners. Now let me share some quick program information. This is our second edition of our middle school program, and it's ready to start piloting now and to purchase beginning fall 2023. All courses have 10 consumable student packets with a teacher edition and lots of other resources in the teacher portal. The core of the program, meaning all grade level standards, can be done in about 100 class hours. So that leaves plenty of time to build in other things that you think are important to maximize student learning. Remember that the content we looked at today is in packet 7. It is the 7th of 10 packets. So if you're trying this packet as a pilot, you'll want to think about how this content will fit in with where your students currently are. Now to wrap things up. Here's our website with lots more information. Under curriculum, you'll find our second edition programs. From here, you can link to the overview and learn more about pilots. Thank you so much for spending time with me today. Feel free to email if you have any questions. It's right there on the bottom of the slide. Have a great day, and I hope to be in contact with you again. Thank you.